Good morning. Today I start with a new chapter. The name of the chapter is Classification of Elements and Periodicity in Properties. My topic today is Classification of Elements. Scientists try to organize their knowledge about the elements by systematically classifying the elements. Different people attempted classification. The initial attempts were based on arranging the elements in the increasing order of the atomic masses. The first person to do so was Dobereiner. He arranged the elements in groups of three called triad. That is, he arranged the elements in the increasing order of the atomic weight in groups of three called triad in such a way that the atomic weight of the middle element is an average of the atomic weight of the first and the last. For example, this is a typical triad where lithium, sodium and potassium are arranged in the increasing order of their atomic masses. The atomic mass of lithium is 7, of sodium is 23 and of potassium is 39. And we find that the atomic mass of sodium is an average of the atomic mass of lithium and potassium. However, this classification failed because all elements could not form triads. Then we have the next person. The next person is Newlands. He arranged the elements once again in the increasing order of the atomic masses, and he found that every eighth element showed property similar to that of the first, just as in the octave of a music where every eighth note is similar to that of the first one. However, law of octaves was also a failure because this law was applicable only up to calcium. Elements beyond calcium did not obey this law. Then we have the next person, Mendeleev. He was a person who introduced the periodic table for the first time. He arranged the elements into horizontal rows and vertical columns in such a manner that the properties of the elements appear at regular intervals. Thus, he introduced the periodic law. According to Mendeleev's periodic law, the properties of elements are periodic function of their atomic masses. Now let me tell you something about Mendeleev's periodic table. This periodic table had certain advantages. He left gaps under certain elements and predicted their existence in future. For example, he left a gap under boron, under aluminium and under silicon, and he named those elements as Eka boron, Eka aluminium and Eka silicon. In future, those elements were discovered and those elements could be easily fitted in that particular place in the periodic table. But his periodic table had certain disadvantages. The disadvantages were hydrogen did not have a fixed position in the periodic table. Second disadvantage, isotopes could not be accommodated in the periodic table. Third disadvantage, many atomic masses were incorrect. For example, the atomic mass of iodine, which is less than that of tellurium, was given a higher atomic mass so that it could be placed in a group just below bromine because of similarity in the properties. But Mendeleev's periodic table is very important because, as I said earlier, for the first time the periodic table was introduced. Next, it was Henry Moseley who said that the atomic number is a more fundamental property than the atomic mass, and thus we have the modern periodic table or the long form of the periodic table. This periodic table consists of 18 columns which are called groups or families and 7 rows which are called periods or series. In the modern periodic table, elements which have same property come in the same group. Thus, This periodic table is based on the modern periodic table law, which states that properties of elements are periodic functions of their atomic number.